Hi, and welcome back to one of our last dot points or outcomes in this module 6, acid and base reactions. And today we're looking at buffers. So the actual outcome is to conduct a practical investigation to prepare a buffer and demonstrate its properties. So we're going to do that in our next lesson. But to conduct a practical investigation to prepare a buffer asks the question, well, what is a buffer? And what are its properties? So let's have a little bit of a brief introduction to what a buffer is. So a buffer solution is an aqueous solution that actually resists those rapid changes in pH when an acid or a base is added. So if you remember back to our titration curves, we had the bit at the beginning where despite us adding acid to the base solution, there wasn't a great change there in the pH. And I spoke to you there about that being due to the buffering effect there. So each buffer that we have has a well-defined pH value. We'll look at those a little bit more when we do our prac. But what actually happens is it contains chemicals that maintains that constant pH when little amounts are being used. And usually our buffer either consists of a weak acid and its conjugate base or a weak base and its conjugate acid. So some examples of our buffers are our ethanoic acid. And you can see here that I've done it all in subscript. So it's CH3COOH and another one, sodium ethanoate. Now you would have seen that these were produced when we were doing our titration with our vinegar and our base there. Carbonic acid and sodium bicarbonate, again, the acid and its conjugate base, are other examples, as well as ammonia and ammonia chloride. Now what happens is our buffer actually resists the change, and the reason that it does this is again due to equilibrium that keeps popping up, that equilibrium between the acid there and its conjugate base. So what happens is the buffer actually has both of these there, and significant amounts of each. So when I add a little bit of strong acid to that buffer, the pH changes much less than we would think. Many of you again were saying, well, I'm adding acid, why isn't it changed? Again, due to that buffering effect there. So the hydrogen ion is increasing, but less than what we would expect. So if you look at a normal equation, again, if I go back to here with my HA is in equilibrium with the hydrogen ions and the anion there. If I increase the H+, so we're adding a whole heap of acid to that there, it's going to move to counter that. If I'm decreasing the hydrogen ion concentration there, it's going to move in the direction to counteract that. So by adding a strong acid is meaning that my H+ is increasing, so with that it's moving to the left. The same can be said with adding a base. So if I'm adding a strong base to the buffer, what's happening now is the hydrogen ions are decreasing. Again, it's not decreasing by as much as I would expect, because what's happening there is our hydroxide ions are reacting with the hydrogen ions and they're forming water. So what's happening is we're getting a decrease in that hydrogen ion concentration. So again, by decreasing that, the equilibrium is moving to the right, and the H+ rises back to what it was really before the base was added. So where do we see this happening? We're going to look at a little bit more, but we talk about something called buffer capacity, and that's its ability to maintain pH. That's what we're wanting it to do. We don't want the pH to change that much, and there's certain circumstances where this is necessary. Our blood is one of them. If we've got an increased amount of carbon dioxide in our blood, that can then affect the pH of our blood, which could be life or death. In our aquariums, you'll notice that you're regularly checking the pH, and sometimes we need to alter that, but we don't want to make that happen too great because we can then be affecting the environment there. So it goes about, I suppose, protecting that pH for a little bit. So where do we use this? In the natural environment, as I've mentioned, two situations already. It's used in many biological systems to maintain that optimum pH that the system works at best. So one of the areas, again, that I've mentioned is in our blood. So I'm going to get you to research that for me. I will be doing that again in class. But how does the pH of the buffer, how is it determined? And we're looking there at our equilibrium constant again, which we were doing in class recently, and looking at the ratio of that weak base to our weak acid in solution.